I'm Mr Yiannis Kanellopoulos from SKEL. Thank you everyone for joining us today for the AI Industry Connect talks. And so we are very happy today to have Yiannis Kanellopoulos from Code4Thought. Will talk to us about many interesting things. As you see, he will talk about fairness, but also going beyond fairness, I think. And he will say, actually, this is quite a strong statement, and this is on my part. So Yiannis has nothing to do with it. He will show us that how accuracy can really make a mess of things when it comes to real life AI applications. Yiannis is a technology startup founder, and he works a lot on fair, accountable, and transparent systems. He has been evaluating large-scale software systems as a PhD researcher, but also as a consultant for over 17 years. And also he has been a practice leader for a Dutch international firm. Yiannis is serving the Orange Grove Incubator, and he's a member of the board of directors. And we also met with Yiannis in the scientific, let me see, test committee that supports the national scientific research and innovation committee that provides suggestions to the Greek government.
On the data and AI policies.
Data policy and AI, exactly. So I think I will now give the floor to Yiannis. So thank you, Yiannis, for being here, and we're looking forward to also to your questions from the audience. By the way, I think Yiannis will present. We can gather questions as we go. If you can, in the questions, please, and I will try to note down the questions and get back to you, Yiannis, after we finish. So let's start and see how it goes. Thank you very much.
Okay. Thank you very much, Giorgo, for the nice introduction. Just to say, and that's kind of a joke that we have about the committees, that we try also to do some work being in a committee in general, because the general perception of somebody being in a committee is that they do nothing. But we are the opposite. We strive to do something. So, good evening, everyone. I'm Yiannis Kanellopoulos. Giorgos had made a very nice introduction. Just to say that I also have since we are among researchers, that I also hold a PhD in the intersection of data mining and software engineering, which I did back in the days at the University of Manchester. And part of this researcher mentality and philosophy still stays with Code4Thought, let's say, and the things that we do. So let me start my presentation. Okay, from start. So today I'm going to talk about a subject which I really like to talk. It is related with the quality and trustworthiness of AI systems, and why these are very important things on top of accuracy, or at least on top of what many teams and clients of ours, we've seen how they fell in the trap of just measuring accuracy and not always with a correct way. So Code4Thought, we found the company.
Yiannis,
yes.
Forgive me for the interruption. You are not sharing your screen, are you? Can you double check? Do you mean to share your screen? I think we stopped it.
Right, I do mean, and I was under the impression that I'm
okay,
sharing my screen.
I understood. Okay.
Right.
Thanks.
So
thank you.
Okay, guys, apologies. It's again, my God. Did I say that I'm very that I'm a little bit stressed because I talk to a different audience that I'm used to? So yeah.
Thank you,
it's me being nervous. So as I said, we founded Code4Thought in 2017 with two main activities. One activity is that we evaluate technical quality of software systems, like code quality architecture, in collaboration with a Dutch company called Software Improvement Group. But the other line of business, the other activity, the one that we are focusing on today, is about trustworthy AI. So we have an R&D team here in Patras, which is our R&D office. And we are building technology that will help us test and audit AI models. We have applied this technology already in proof of concepts, but also in real life projects. So some of the things that I'm going to share with you are based on this experience. Some other things are based on what is the state of practice today. But in general, I'll try to stick as close as possible to what we do at Code4Thought, but also the foundations, the research foundations of what we do. We have, as I said, we have an R&D center in Patras. We have also a delivery office in Athens. In total, we are a company of 10 people, including software engineering consultants, sales, and office management. We are investing a lot in R&D. Everything that we do in our company is fully funded by us, by our profits. We want to maintain strong and even stronger ties with academia. The clients that we work with are usually corporations, so either the market leaders in the banking sector or in the telecom sector. Especially in the trustworthy AI area, we work mainly with companies abroad, in Germany, in the Netherlands, and in other countries. And we try to be a team which really likes to learn, both at business level and also at the research level. Let's say our mission as a company is that we want to help organizations to make technology trusted and thoughtful. What we see in the market, and by market I mean not only Greece, but European mainly, is that lots of companies that are striving to solve business problems with the systems they build or they buy. But sometimes instead of solving your business problem, you start cutting corners, especially in the quality of your system or in the way it behaves and the risks it creates. And all of these things are coming as an afterthought. So if something bad happens, then you try to, resolve the problem instead of prevent it. So what we want actually is to help organizations to start building systems from scratch, or at least from their design phase, to start to try and incorporate values related to quality or trustworthiness in order to mitigate any subsequent risks as soon as possible. Recently, we won a contest in AI that was organized by the Embassy of the UK as part of a greater program initiated by the Department of International Trade, which is a program that runs all over Europe. We are the country winner on the artificial intelligence sector, but we are kind of proud about it. And now we have discussions of how we can expand as a company in the UK. As I said, we believe a lot in research. We try to publish ourselves. This is a selection of our articles, either in books, in journals, and academic conference. So far, the areas that we'd like to publish are in the area of explainable AI, in the area of accountability, or another way, the way we govern our AI systems. We are also very interested in the research on bias, evaluation, and mitigation. There are plenty of papers and work on how we can evaluate bias, but there is not so much work on how we can mitigate it. So this is an area of interest from our side. And this year, we have sent a couple of papers that are under review and are mainly related in the area of bias and recommendation systems. Probably, the problems created by with Facebook newsfeed algorithm or other recommendation algorithms such as Netflix's. And by looking on things like popularity bias, we try to see whether they work as they're supposed to. And by telling this, I'd like to share this slide with you. I mean, if anyone tries to, this is a selection of articles indicating problems that are stemming from the use of AI systems and algorithms. Anyone who can Google about it in this week, they can find way more every 2 or 3 weeks, and so there are publications like that. If I had to handpick one, that would be this article that talks about the machine bias and the prediction of future criminals, because actually that was one of the very first articles in the news, in the public news, that was talking about the bias in AI algorithms, and then it created the whole the whole fuss about it. Essentially, this is quite well known as the ProPublica article, because that was the medium that this article was first published. And what essentially this article was telling is that if, let's say, I have a criminal who's white and a criminal who's like either black or people of color, then the algorithm will have the tendency for the same type of crime to give a bit bigger, let's say, sentences, or more graver sentences to the people of color compared to white people. But there are several cases where we see that algorithms are going awry, but that's the social impact. If you try to persuade an organization that they have to do something with their AI systems, then you need something more than the social impact. You may need to give some percentages or some risks or some costs that they are so they can associate it with money. And there are a series of research done by Gartner, Forrester, PricewaterhouseCoopers, that they indicate that a vast majority of AI projects is not going to deliver the return on investment promised, or they're not going to deliver the value that somebody expects, either due to bias, either due to problems in the data, or how one can be persuaded about the transparency or the results that these systems provide them. And as a consequence, the investment stops, the projects are being killed, and companies have spent money, but they didn't get anything. So actually they wasted money by investing in AI technologies. So this actually makes things more problematic. So we need to do something in order to actually start helping AI investments deliver what they promise, and then help increasing the adoption of AI. There is a thing that people are, there is a certain type of technology that is known as RegTech, regulatory technology. And if we want the state of the market right now, or the state of practice right now on when it comes to responsible AI and regulatory technology, is that there are companies that actually are working on these four main areas. The fairness area, which is focusing on detection and prevention of discrimination and bias in different demographics or in different types of groups in people. Then there are the explainability technologies, whose goal is to explain and interpret the outcome of a given algorithm to its stakeholders in a way that they can understand it, that they don't have to be machine learning engineers to understand it. Then the technologies which are related to auditability and accountability, so technologies that will help us, third-party regulators, to challenge a test and a model. And last, and definitely not least, there are the safety technologies. Is that technologies that help us make sure that a model is not going to be harassed, or is not going to be exploited by a malicious attacker. So these are the main four areas we see technology being developed in order to ensure that an AI system is responsible. And in general, these are also the areas that we at Code4Thought are working. In order actually to give some more ground and some more basis on those technologies, the ISO 29119 has been developed, which is a standard that helps. It actually provides guidelines for testing an AI system. The premise of this standard is that testing a traditional software system, which has like thousands or millions, actually millions of lines of code, is more or less determined, is more or less defined. But if we consider that AI systems are software systems, but with a different, let's say, behavior and different aspects that one needs to take into account, then we need another way to test them. And this is the goal of this ISO, to provide guidelines for testing AI systems. And what does this ISO dictate? It dictates 7 quality properties that one must take into account when it comes to an AI system. The 3 of them, which are most, let's say, they are also in the focus of the upcoming regulations or their legal requirements, are the ones related to bias, transparency, and flexibility/adaptability, or else, which is related with security and safety mainly. So these are the 3 main areas that we are working, because we see also more that there are most critical and the ones dictated by the regulations. So, and if you want to understand a little bit better what these 3 areas are concerned, the first one, which is about testing for bias, is that if we're given a data set and also the models in certain cases, then we can evaluate it if there are any unwanted patterns there. The explainability analysis is related to providing a level of understanding on how an AI system came up with a given result. We have a more thorough definition on that later on. And robustness, which is, for us, it's pretty important because it's mainly related with the safety and security of a system, is mainly, or at least we are focusing on performing adversarial attacks by doing black box attacks to given models. These are the 3 areas that we are working, and these are how they are defined in the ISO 29119. But before we start elaborating on those properties, let's say, it is important for understand to the gap between the quality and between the trustworthiness. So our thesis, let's say, or our belief is that all these aspects related to trustworthiness of a given system are in addition to the essential qualities of it. So we build a system, an AI system, and first and foremost, we want it to be accurate or efficient or to have good performance. So to deliver, let's say, its promise to the users, to deliver its business value. And if we don't kind of succeed that, then trustworthiness is not possible. So first, we want to have a system which is operational, more or less, and then the whole spectrum of trustworthiness can be applied. This is what happens now. In the ideal world, we want or when we start building a system, we want all these properties and qualities to be interrelated, and a team will need to take them into account from the inception and the design of the system. So not only to care about its accuracy or efficiency, but also to care about how fair it is, how transparent, and so on. And with that thing in mind, so when we audit a system, so the first thing we want to do is to check whether the system, the team measures its accuracy in a proper way. For the rest, for a large part of the discussion, I'm going to use an example data set in order to demonstrate how what are the things we look, what are the results that one can expect. So this is a screenshot from the so-called adult data set. So this data set is, first of all, it's a structured data set. You see the features like age, sex, and so on. And this data set comes from the financial sector. So imagine that you are a bank, you have this kind of data, and you want to identify potential customers who have more than $50,000 as an annual income. So you can try and sell them certain banking products, and you won't select only those people and not people with less than that, because they're not going to buy your products, or they're not going to buy a credit card or a loan from you. So you want to identify who might be the best customers to approach for your products. Let's say if so we train our model, then we test it, and we see that the test results say that the model has 97% accuracy. So the team is really happy, is proud. They believe that they built the best model there is out there. But if we go back to the training data set, and then we look where we know also we know the label who actually has the income more or less of $50,000 per year, the annual income, we can see that the vast majority of my of my population has income less than $50,000 $50,000, sorry, and only a fraction of it has the required, let's say, income, which means actually that this 97% of accuracy, so who is less or who's more of 50,000 euro, doesn't actually say anything, because the only thing we look is a very small fraction. We want to identify is a very small fraction of the population that we use in our training, which actually it brings bad news to the team, because they have to change the way they measure the accuracy or the performance of their model. And in that case, what we have seen and what we have suggested teams is that they can, in order to get better results or identify better to evaluate in a better way and more, let's say, credible way the performance of their model, then they shall use the precision and recall metrics in order to be able to see how bad or how good it works. So if then, let's say, for this data set, we run this analysis, I presume that more or less we all know what the precision and recall is, so I'm going to skip, let's say, the definitions. But what we see here is that actually the model is really bad in identity. It's really good in predicting who's going to have this income, because actually this is the goal, but it's really bad in identifying those people from the general population. So this 22% of recall means that actually the model identified only 1/5 of the people in our population, in our data set, who have income of more than $50,000 dollars. So the bank can contact them, which means that actually the bank may be losing opportunities, maybe losing money by operating this model. But so this is the first thing. So the first thing that we do is we try to see if the model or the team, they have fallen to the thing that we call the accuracy fallacy. Then the next thing, the next thing, which is very interesting, especially in the financial sector, because also due to GDPR, especially for negative results, organizations are, let's say, obliged to provide explanations of the decision made out of an algorithmic system in a way which can be understood by non-technical people. So we see that there are three levels of explainability. The first level is the transparency, which means that actually when somebody interacts with an AI system, he shall know about it. So somebody has to inform them that they are interacting with an algorithm, and also in reality, they shall also inform about the type of the algorithm and the type of the data they used in order to train this algorithm. The interpretability, it's one level deeper from transparency, which means to understand how the technology works and be able to figure out the underpinnings of the technology. And the explainability is how to understand how an AI system came up with a given result. So to explain the decision to explain the specific decision of a given AI system. We believe that explainability and interpretability are, let's say, very important. Of course, the same goes for transparency, but let's say in the next slides, we're going to talk more about explainability. So how to understand how an AI system came with a given result. A very interesting method for explaining decisions is the so-called future importance. There are several ways to do that. We like to work either with supply values or with finding future importances using permutations. This picture is the so-called global explanation of a model for the data set we discussed before. So what does this picture actually tell us? That for the population I have used the model, for the whole population actually, the main features that are most important in order to define if a person has an annual income less or more than 50K are first of all the capital gain. So how much money this person probably gain from his investments in the bank, the capital loss, how much they lost. But there are two very interesting things that happening here is that we see that age and sex actually are playing some role, play important role for these decisions that we talk about, which means that some sensitive attributes are playing an important role here. This is not necessarily bad if somebody asks me, because by trying to omitting the sensitive attributes on the data set in order not to play a role, then actually we open the Pandora's box for more problems, but we can talk about that later. But let's just say that this is what is happening. This is the so-called global explanation, which is how the model works for the general population it has been used, for the overall population. Then there is another level of explanations, the so-called local explanations, which are related to the following: how did the model think for a specific instance, for a specific client, or for a specific image if we had an image data set. And here one can use methods like the SAP method or LIME, which is a very well known. Both of them are very known explanation methods. We have below you can find also the link from the GitHub repositories. They are open source projects, so you can actually download them and use them to your liking. And here we can see, for instance, that for this specific ID, for the client 477, again here we had the capital gain playing an important role. Then we had his type of education, and then his age and sex, which are more or less also similar to what are the global explanations about. And the interesting thing here is that the Lime has a different way to see things. I mean, there is some agreement on the most important factor, but the rest changes. And this is, if you ask me, a bit of a drawback of the model agnostic techniques or the post-hoc explanations, because there is not one single single truth. There is no a single type of explanation. And there are some, if somebody wants to understand better how we can, let's say, the taxonomies of post-hoc explainability methods, one shall try to define whether a model is going to use an intrinsically explainable model, or they're going to use a post-hoc explanations. Are they going to focus on local or global or both? Whether the methods they're going to use are going to be model specific or model agnostic. And then there are different types of interpretations, either with feature contributions or with surrogate trees. You name it. There is a very nice book about all those stuff written by Christophe Molnar. So we have the reference here. You can take a look to investigate more. Here you can see some examples, for instance, of how to explain. We explain an image that, for instance, a system show a dog. What were the most important areas in the picture that the model show and classified as a dog, and so on. So on the fairness methods, if you remember, I said that there are plenty of ways to measure fairness or to measure bias.
Yanni, a very short interruption. We have 20 more minutes in total. Just I promised to give this feedback. So please go on.
Okay, 20
For
minutes
the whole, including questions.
Okay, then give me 10 more minutes and...
Of course. Please go on. Thanks.
Okay, so there are, let's say, more than 21 definitions of fairness. So I'll skip that slide and I'll go to this, let's say, image. So what we see here actually is, let's say, work that we did based on this data set that you see that we talked before. Essentially, what we see here is that the model is more prone to identify men as, let's say, more having an income of more than 50K, and in reality, women identifies less women, although there's a very significant percentage of women in our population, which shows that the model has a certain bias towards men. And if we want, let's say, to make it more concrete, there are a couple of metrics that are quite credible in measuring bias in the dataset. There is a disparate impact ratio, which takes the ratios of favorable outcomes against the non-unfavorable for a privileged or unprivileged group. And then there is the quality of opportunity, which measures the ratios of true positives. There are two different ways to measure more, but these two specific metrics are the ones who have been there are lots of free references also in the legal literature, and they abide and they follow the 4/5 rule. So one can set a threshold there of the percentage of the bad decisions against unwanted against sensitive groups, and that actually helps us in order to, by setting the threshold, we can judge, evaluate in a more concrete way how a model does from a bias perspective. The disparate impact ratio is defined mainly in the US legislation. The equality of opportunity is mainly defined in the EU legislation. Here we see, for instance, that the model is clearly favoring men against women. It's not really visible here, so apologies for the clearly, but this 0.15, this is a very low value for this particular metric. We want this metric to be between 80 to 120% when we judge the protected attribute, the group which is more, let's say, the unprivileged one. And this is also a nice statistical way to measure it. In this nice visualization, you can see the types of bias and the types of fairness metrics one can use in order to judge whether a data set or a model have indications of bias. One can ask where we can mitigate bias. The answer is whenever you can, in a sense. Either you can try to mitigate it in the training phase, or when you develop your model, which is the so-called in-processing bias mitigation, or when you test it and you identify the biases, then you can try to do some mitigations on the post-processing before you launch your model. There are 3 different stages. And if I have to let's say, then that's enough about fairness, I think. More we can discuss later or offline. Now, safety. Safety is very important. It's related also to, is interrelated to security. And we all know that data and AI models can be target of malicious users. And by trying to test a model against those adversarial attacks, we can see its level of robustness and how safe it is. So I'm going to skip a little bit those slides. The reason here is that the focus in this presentation is mainly on the supervised learning models. So the thing is this: I'm not sure who is how aware you're about those things, but the so-called adversarial attacks, what does it actually mean is that if I kind of change slightly a pixel of a picture, I can change the label. So as you see on the left, I had a picture classified as pig with 91% confidence. Then I added some noise to the picture, and I made it say, I made the model say that this is an airliner. It's an airplane. And on the right side, you can see that just by rotating a picture, I changed the diagnosis from tumor, from a small in the skin, from a small olive in the skin, from benign it became to malignant, which is cacoethia. Or also by changing certain words in a text, I can change the whole meaning, let's say, of the paragraph. This is a video. I'm not going to show it now. It's not only we can manipulate images, we can also manipulate the explanations of those images, which makes things even more interesting, let's say. And not only that, by, let's say, doing the so-called data poisoning, but trying to change slightly an image on the training data set, we can actually poison the whole training process, and we can change the prediction of we can change the behavior of the model. And this is, let's say, a very interesting example with the dog that by adding some noise, then the label changed to fish, and that led also to change the labels in other pictures as well, because the model has been heavily influenced by that particular picture. And same goes also for this in the example on the right. By changing a small pixel in the picture, then the van became a dog for our model. A typical question we hear from our clients is that, let's say that if we restrict access to our model or to make it more difficult to access, does this help making more secure? The answer is not fully, because still there are ways to let's say exploit it by, first of all, reverse engineering the model, and then by trying to construct adversarial dataset or adversarial attacks from queries to the model. So you have to be always able to monitor the behavior of your model, or also from a security point of view. There are two different ways to evaluate robustness. It's the game-based approach that we typically follow. It's a verification-based approach, which is, let's say, more. It can go deeper. It is, let's say, more credible to a certain extent, but it's really time-consuming, and it requires lots of time. It's so time-consuming in resources, let's say, so to do it properly. And especially for large neural networks, is becoming really cumbersome. How we can defend? How we can build defenses? The first comes from experience. So try to create your own adversarial examples based on the training results, and then add them again to the training dataset. And the other is this certified, let's say, try to prove that the classifier is certifiably robust, but this mainly lies in the area of formal verification, which again is cumbersome, difficult, and can be applied to a certain type of models and a certain size of them. Just to say a little bit about the technology that we built, we call it Pythia. It does essentially three things. It bias AI systems. It tests AI systems for bias. It provides an explainability analysis of the results, and it tests them for robustness. Last year, we have been contacted from a Dutch company that they have created an algorithm that's called Nightmares. And what this algorithm does essentially is to monitor patients at night in their beds and see if they fell off their bed or not. And if it detects the fall, then it gives an alert to the nurses. It's used mainly in care homes for elderly people. And the team that built this algorithm has been asked by the clients, the trusts operating the care homes, and their investors, whether they can trust the system and how they can trust it beyond the fact that it had an accuracy of 90–80%. So we came into play. We explained them what we're going to do, what are the things that we're going to look. Actually, the whole test and audit went pretty well. There were some issues. The team fixed them, so the system was able to go to production in a trustworthy way, let's just say. That led to a nice press release from them that was circulated, especially in the Northern Europe area. So this is from me. I hope I stick to the timeline, Yorgo.
No, I think it's fine. We have almost 10 minutes for questions. Not much, but still, thank you very much, Yiannis. I think it's good enough. So let us activate the audience, already active audience. So the question is from Demokritos Mavroidis. Is there some kind of certification for ISO 29119-11 compliance? And if so, and if you offer this.
Yes, the answer is not yet. There is no such certification. This standard is mainly used as a guidance, as the ISO organization dictates. There is an upcoming ISO on the quality of AI systems, which is going to be in public discussion in the next 3 weeks, three months or so, about certifiable aspects of an AI system. We are having this kind of discussions with a certification body in Germany to do that. So probably we will be able to offer a certain level of certification for an AI system within the next month or so. And this is what we're currently working.
Excellent, Yiannis. Thank you very much. One question from Fotis Esopos. So the question is, does reducing bias lower significantly the overall model performance? I think you gave a hint at some point there. And
Yes.
also, can we perhaps blame the bias on the data itself in some case? So it's a two-part question.
These are actually not naive questions at all. They're pretty normal, actually. Yes, when there is a so-called dichotomy between bias optimization in the expense of accuracy of the model, that is why we say we need to try to keep the balance from the start of designing and the inception of an AI system in order to keep this balance between, because there is this controversy. Ourselves, we're doing some research and we published some results on fairness awareness bugging algorithms. So we have developed one algorithm that one can say it is inherently fair, let's say, or it takes fairness into account from its design, which means that you may sacrifice a little bit of accuracy, but you gain a lot in terms of, let's say, protect you from bias. But yes, it is possible if you try to just play with the metrics, you're going to do some harm by trying to fix only the bias. On the other hand, one of the reasons that we look on the training data sets and we look also there for biases is to identify just that, to see whether the distributions of my population are and how they promote bias itself. So then you can mitigate it accordingly in the next phases of your development. And I think this is the important thing here, to be able to identify bias as early as possible, because there are ways to mitigate it. The whole point is not to monitor or not to test your models for the existence of bias.
Thank you very much, Yiannis. I think Dimitris Kalles has raised their hand. So Dimitris, I will ask you to unmute. I will push the button here. Okay, okay, thanks. Thank you.
Thanks a lot. Thanks, Yiannis, for the talk. I have one more generic question, which is, for, let's say, decades now, we've been clicking on I accept on all terms and conditions for very, conventional software at the user level. Now, the AI Act and regulation seems that, at least the EU wants to put us a bit more in control. Do you think that trend might move a bit towards, as exercising some more control over conventional software, let's say, other services that we use, not just AI systems?
To be honest, the AI Act is focusing to a specific category of systems. And it is very interesting because they have defined, in the legislation, they have defined, EU has defined what they consider as AI. So apart from, let's say, machine learning systems and deep learning, as AI, EU considers any system that has, for instance, even an advanced spreadsheet that does optimization, tries to solve optimization problems, is considered AI. So it all depends then what we define as AI and how broad this definition will be. And if you ask me, trying to gain more control on how our data are being used by these kind of systems, I think it's a good thing, essentially, because especially the systems that are processing our data in order to form a decision, we need to be way more aware how our data have been used or exploited. I mean, right now they're being exploited because we have no clue of what is happening with our data. Now, if this becomes, let's say, an horizontal thing for any kind of software, I think this will start creating problems instead of solving problems. So again, every regulation needs to take into account how they want to promote innovation or how they want to block innovation. For me, the whole discussion, especially in Europe right now, is being the main debates are in two areas: what we define as AI, and the second is what we define as high-risk AI. And there are lots of compromises being done as we speak on those two aspects.
Thank you very much, Yiannis. And I think Yorgos Palliouras, you want to talk if you have time? You are still here.
Yeah, just a common question. First of all, thank you very much, Yiannis, for the interesting talk. The way I understand it is we want to check the existence of bias in two different at two different levels. One is the data, and the other is the model. And in order to do that, we need I will call it a bias detection model. And so far, from the examples that I have seen, these bias detection models are looking for specific correlations or specific patterns, which we as humans have thought that might be worth looking for. Clearly, there may be other types of bias that we don't know yet. So I wonder eventually whether we are gradually getting into the need for an AI system that will be detecting bias in other AI systems. And if that is the case, then whether this controlling AI system needs to be checked for bias.
Who audits the auditors, right?
Yeah.
Yeah, I think our approach is a bit practical in that perspective, because we are also thinking along those lines. First of all, I think that we don't necessarily need an AI to measure other AIs, because bias, in any case, the ways you can measure it are pretty straightforward, and really they are stemming from statistics, just that. The main problem with these metrics, they are simple, there are thresholds, you can say something, but then again, it's how you interpret them. And it all comes down to the human being, it's to the human, so yeah, we've heard about it several times, the human in the loop, but you need somebody to actually be able to interpret this metric and identify if this is a good or bad thing, or this is a normal thing happening. And in general, I was reading a very nice article the other day that was telling that the fairness is not just following the 4/5 rule and abiding to the threshold. And I tend to agree, actually, because there are cases that the presence of bias actually is normal and makes some sense. So you don't need an AI necessarily to measure it. You need good interpretation skills of those metrics, and you know how to apply it and where to apply it. And also another subjective thing is which are the groups in the data set that like to measure whether there is bias. Why do I think that white men are the privileged group and not the other way around? Because, for instance, if I am, let's say, in Africa, there might be the case that the white men can be the unprivileged group and black men can be the privileged. I mean, right now I'm just trying, this is me philosophizing, right? I don't think this is happening actually, but I'm just trying to indicate here how subjective things are before even we start the audit. We have the metric, but how we define things before the audit are very important. And so far, it all comes down to the auditor, so it comes down to humans to decide how and what they're going to measure. That is the one. On the other hand, it's, let's say, and I think also that Code4Thought falls in this category. There are ways to ensure that, let's say, the regulatory technology follows certain standards and best practices in order to measure things. So it's not easy to say that you measure things not correctly, you capture the context with your measurements, but at least companies like us can prove that our measurements are credible and the results have been produced by a scientific way and a repeatable way which can be accepted. And there are these kind of standards that companies like us shall adhere.
Thank you very much, Yiannis. we are 4 minutes after 3, but I would like to ask a last question. If no one else has asked, I didn't see anyone. So Yiannis, your job at Code4Thought is mostly about consulting. Is it also, or is it mostly based on Pythia as a pipeline or software engineering solution or software solution anyway, to asserting AI, or a combination of both?
It has started as consulting. It goes right now. It's becoming as a combination, but not as a part of a pipeline. We mainly want Pythia as like a separate thing to test and not an AI system. And the goal is to switch it to product mode within the next 2 or 3 years.
Thank you. And I expect that already you are active in EU proposals, because I feel that also there is a large
yes.
Okay. Yiannis, thank you very, very much. I think there is a way to upload, but I don't remember it. So thank you very much, Yiannis.
Okay.
And looking forward to hearing more from you in the future.
Thank you,
So
guys.
thank you everyone for attending. Ευχαριστούμε πολύ, Γιάννη.